Hello to all. To those of you just joining us, welcome. To loyal viewers watching this, welcome back. Last week, we introduced a graph and the table method of plotting out a function to find its graph. Although the table method is solid and works no matter what type of function you're trying to graph, it is slow and really difficult to do once you get to more complex equations. Because of that, there are several different techniques to graphing a function that are much easier and much faster. This week we're going to start off simple, just graphing the equation of a line. Before we go to graphing it, there's two parts of the equation of a line that you need to know. First off, we can represent such an equation as y equals mx plus b, where m and b are numbers that are always given. M is something called the slope of the line. The slope of a line is how sharply it increases or decreases in the y direction. No matter what, the slope is always rise over run, or in other words, the amount y increases or decreases over the amount x increases. So, say the slope of a line is 3/2. We know that for every increase of 2 in the x direction, the line increases by 3 in the y direction. Keep this in mind for later. The b in the equation of a line is called the y-intercept. This is where the line crosses the y-axis, or in other words, where x equals 0. Now that we know those two things, we are ready to quickly graph a line. Our equation this time will be y equals 3/4 x plus 1. Start off plotting the y-intercept. In this case, the y-intercept is 1, as 1 is in the place of b. Next, count out the slope to plot the next points. Remember, rise over run, so we go over 4 and up 3, then plot a point. You can do this also in the negative direction, going the opposite way for both rise and run. Go back 4 and down 3. Then draw a straight line through these points. If you did it right, they should all connect on one single line. Let's try a practice example. Try graphing y equals 2x minus 2. I'll be doing it in the background as usual, but only check if you absolutely need help. Alright, so you should have a line that looks like mine. If not, it's time to rewind and check where you might have gone wrong. And that's everything for today. Next week, we're going to go through the tricks to solving a quadratic equation. Until then, keep on learning.